Let's solve one more question on this. Assume that we have a bag, and in this bag there are m red balls and n green balls. So now we'll conduct an experiment in which we are going to draw a ball, and if the ball happens to be green, we are going to add, along with this originally drawn green, plus k green balls into the bag. If the ball happens to be red, along with this k that withdrawn red, we are going to add k red balls into the bag, and then we are going to draw the second ball. Okay, did you understand the question? Question is, we are going to conduct an experiment in which we draw a ball from the bag, and then after drawing the ball, if the ball happens to be a green ball, we'll place that original ball back, which means the total number of balls will remain unchanged. Along with that, we add k green balls if the originally drawn ball is green. In case if the ball which we have drawn happen to be red, we place the red ball back, which means the number of balls here will remain unchanged. Along with those balls, we are going to add k red balls into the bag. Therefore, depending on the ball that you have drawn, either the red balls are going to increase or the green balls are going to increase by a number k. And after this, we are going to draw the second ball. So the experiment contains of drawing ball two times. First time we draw a ball, add it back, along with that we are going to add k balls, and second time from the total balls we again draw a second ball, right? So now what does the sample space contain? The sample space contain 4 events basically. So you might draw green one first, and the second one can be a red ball, or you might draw green one first and the second one might be a green ball, or you might draw a red one first and the second one may be a red ball, or you might draw a red one first and the second one might be a green ball. Now what are the various questions that can be asked on this? So first thing is, before asking, if you want to solve any question on reverse probability, you should first analyze the total probability, and after finding the total probability we shall go for the reverse probability. Okay, so one kind of question they can ask is, what is the probability that the second ball happens to be red, which means this is what they are asking. Got it? So in order to solve this, again using total probability theorem, you have to divide the sample space into 2 events based on what happens in the first ball. If the first ball happens to be green or the first ball happens to be red. Got it? And our required event is actually spread across these 2 mutually exclusive events. So we can apply the total probability there, right? So what is the probability of getting the red ball when I draw it for the second time? It is equal to probability that we get the green ball first and red ball second, plus probability that we get the red ball first and red ball second. Now how can you evaluate it? Again by using conditional probability, because these 2 events are dependent. The reason is, initially drawing green ball or drawing red ball are independent. I mean, they don't depend on what happens, but later second time when you're drawing it, that depends on what happened in the first time. Okay, see this? For that reason, let's write all the probabilities. Probability of getting green ball first is equal to, out of m plus n balls, the number of green balls happen to be how many? N balls. That is equal to n by m plus n, right? And probability of getting a red ball, which means R1, is equal to m by m plus n. Now what happens is, if I draw a green ball, then I am going to add the green ball back, along with that I am going to add k green balls. Therefore the number of green balls will be n plus k and the red balls will be same. If I draw a red ball, I'll add the red ball back, along with that I will add k red balls, which means m plus k red balls will be there and n green balls will be there. These are the 2 cases, right? So now let's analyze this one. What is the probability of getting a red ball given that we have drawn a green ball in the beginning. This is equal to how much? So what is the probability of getting a red ball given that we have drawn a green ball in the beginning? So if you have drawn a green ball in the beginning, you are going to add the green ball back. Along with that we are going to add k green balls, but the red balls doesn't change. So red balls are going to be m itself, but the total number of balls are going to be m plus n plus k. Got it? Why? This is going to be green balls and this is going to be red balls. Got it? Similarly, probability of getting a red ball given that we have drawn the red ball first. In this case, the number of red balls are going to increase by k, which means m plus k divided by m plus k plus n. This is the number of red balls now. Given that red ball is drawn, the number of red balls are going to increase. Given that green ball is drawn, the number of green balls are going to increase. Depending on that, I have evaluated it. Right? Similarly, you can even find out what is the probability of getting a green ball given that we have got the green ball first. In this case, the number of green balls will increase. The number of green balls are going to be n plus k. Total number of balls are going to be n plus k plus m. This is the green balls and this is the total balls, right? And similarly, probability of getting a green ball given that we got a red ball first is going to be, the number of green balls doesn't change, but the number of total balls will change because the number of red balls are increased by k now. This is the number of red balls. So these are all the probabilities that we got now, right? And using this we can directly get, substitute them in this formula. Now what about this one, P of G1 intersection R2? It is nothing but probability of getting a green ball first into probability of getting a red ball second, given that we got the green ball first, plus probability of getting a red ball first into probability of getting a red ball second time, given that we got the red ball first. And we can substitute all these values in them and we can get the required answer. Alright, and similarly we can even think about this probability of getting green ball second time is equal to probability of getting this one, right? This is the event that we are talking about. Probability of getting green ball first and green ball second time plus probability of getting red ball first and green ball second time, which is equal to probability of getting green ball first into probability of getting green ball given that green ball has come first plus probability of getting red ball first into probability of getting green ball given that we got red ball first. So we know this one, this one, this one, this one. We know this one, this one, this one, this one. Just now I have written all of them, right? And that is how we can find out the total probability. So total probability theorem can be used to evaluate this. And now let's say I want to find out the cause, which means given that we have already got the red ball, okay, what is the probability that the ball originally drawn first time happens to be red? It is reverse probability. Got it? Now I want to analyze the cause, and also given that red ball has come out, what is the probability that original drawing gave me a green ball? And given that green ball has come out second time, what is the probability that red ball has come out first time? Given that green ball has come out second time, what is the probability that green ball has come out first time? Now how can we answer it? By using the conditional probability formula or Bayes, right? So what is it? P of R1 intersection R2 divided by P of R2. Now what is P of R2? Total probability of getting R2, which we have already evaluated. And what is P of R1 intersection R2? It is nothing but this factor. Using conditional probability, using total probability we evaluate it, using conditional probability we evaluate it, right? What about this one? It is P of G1 intersection R2 divided by P of R2. What about this? P of R1 intersection G2 divided by P of G2. I think you know how to evaluate it. This is total probability and this is the factor which we know already. Total probability is this one and this factor is nothing but this one, conditional probability. And what about this one? Using total probability P of G2, which means this one, this entire thing, and R1 intersection G is nothing but this one, which means this one. Got it? And what about this one? P of G1 intersection G2 divided by P of G2. P of G2 is total probability and P of G1 intersection G2 is this one. Got it? So this is how we can evaluate the reverse probabilities. So given these events, given these I think 6, right? Given these 6, we can find out the total probability as well as all the reverse probabilities. In GATE they will ask you any one of them. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.